We're now going to start Chapter 7, Section 1, which begins to discuss solutions. In order to figure out solutions, you have to know the electronegativity in Chapter 4, so that way you're able to know what can be mixed together. So if you haven't already reviewed that, make sure you do so. Solutions are always a homogeneous mixture. Now that word is actually pronounced two different ways depending on whether or not you're a chemist or if you are just a regular person on the street. Chemists refer to it as homogeneous. However, it has been pronounced homogeneous. So if you hear that word, that means the exact same thing. And what essentially it's saying is that we have two compounds. For instance, we have salt here, and it's getting mixed with water, that are going to be mixed together completely. And essentially what's happening is that the salt molecules are being attracted to the water molecules. So there is sufficient attraction between those two. Solute is the item being dissolved. While the solvent is what is being dissolved in. So we're looking at the solvent, it is the much larger process. So when we're looking at the salt and the water is going to be your solvent. Your salt is going to be your solute. Now these things are going to be mixed together. When they mix together, they're spreading apart evenly throughout the solution. So they don't just stay in one area. If you give it enough time, this cup or sulfate here will float all the way to the top. And it's going to be exactly the same throughout. Just like if you had a cup of sugar water or Kool-Aid. Your first sip of Kool-Aid, assuming you don't put too much sugar in it, your first sip of Kool-Aid is going to taste the same as your last sip of Kool-Aid. Your first sip of tea is going to taste the same as your last sip of tea. That's because the molecules are spreading out evenly. It can't be separated by filtration. What that means is that there's no actual particles in there. There's no little flakes or anything like that are floating there. You can't actually see it unless it's a color. You can, however, boil it and have the stuff the solvent boil off and be left with the solute, or whichever one has the higher boiling point. For instance, if you have a glass of salt water, you can boil it and the water will evaporate off, but the salt will still remain in the pan. Solutes or solutions can be gas, liquid, and solid. Most people only think about the liquid solutions, but it can actually be any three of those physical states. For instance, a gas solution is air, the air we breathe. It's not just oxygen. It's oxygen and nitrogen, and it could be other molecules as well, but those are the two primary ones. It could be in a liquid, for instance, carbon dioxide gas mixed with water or soda water. Vinegar, acetic acid with water. So two liquids mixed together, a solid and a liquid being mixed together. For instance, salt and water being mixed together. It could actually even be a solid. For instance, being up where we are, we're near the steel mills a lot. Steel is actually considered a solid because it's primarily carbon and iron. Those things mixed together perfectly even. If it wasn't perfectly even, there would be issues as far as the stability. So it's a good thing that they are actually a solution. So do not confuse the word solution with liquid, like most people do. It could be liquid, solid, or gas. Water is the primary solvent. Most of the time, if you see water there, it's going to be the solvent. It's going to be what's in the higher majority as far as the molecules are concerned. So therefore, that automatically puts it as the solvent and not the solute. It's polar. If you remember what we said in chapter 4, here's the periodic table. Here's fluorine. Fluorine's the most electronegative. Oxygen's right here. Hydrogen's over here. I believe oxygen's like 3.5 and hydrogen's 2.1 as far as electronegativity. That's a rather large difference in electronegativity. That's making it a polar bond and a polar molecule altogether. So here's hydrogen, who's partially positive because the oxygen's taken away its electrons. And here's the electron, who's partially negative because it's taking hydrogens. While this negative and this positive here become attracted to one another. That's what those dotted lines mean, is that they're attracted to one another. That forms what they call a hydrogen bond. Do not confuse it. Hydrogen bond is not this. Hydrogen bond is the dotted line. What that is it's an attraction between. Not in the molecule itself, but between the molecules. So here's one molecule, here's another one. It's the attraction between those two. That's the hydrogen bond. Alright, so ionic and polar compounds dissolve very easily in water. For instance, here's our water molecule. Here's that hydrogen. It's still partially positive. If we're looking at sodium chloride, if we're looking at salt, this would be the chlorine. The positive would be the sodium. Notice that the chlorine is actually attracted to this hydrogen. There's that hydrogen bonding that we were talking about. That's the attraction. And then that attraction actually pulls that ion away from the rest of it. And then on this side, here's oxygen, which has more of a negative charge. It's getting attracted to the sodium, and it just kind of picks at it piece by piece. Notice that all the hydrogens here are facing the chlorine because they're attracted to that negative sign, the opposite charges. And here's sodium. The red part is oxygen, and it's partially negative. It's attracted to the positive charge of sodium. So it's picking off the ions one by one. In order to do that, you have to have charges there to begin with. If you don't have these charges here, the water can't pick away at it because the water has a charge. So, in other words, if you have a polar solvent such as water, as an example, you can only dissolve a polar compound or an ionic compound. If you have a nonpolar, it's going to be able to dissolve the nonpolar. You cannot dissolve, will not form. You cannot dissolve a polar or ionic compound in a nonpolar thing. They have to be the same. Like dissolves like. And they're talking about the polarity when they're referring to that. Like dissolves like. Polarity. So if it's polar, it's going to dissolve in something polar. If it's nonpolar, it's going to dissolve in something nonpolar. These are obviously differences in polarity, and they didn't dissolve. Alright, so just a couple general checks. Which is the solute and which is the solvent? When you're looking at it, the smaller amount is always going to be the solute. And if it's water, the water is always the solvent, which means the other part is a solute. So here's sugar. It's mixed with water. That's going to be the solute. Water is going to be the solvent. 60 versus 30. Because this one's smaller, that's going to be the solute. And this is the solute because it's not water. 55 milliliters of water and 1.5 grams of sodium chloride. The solute. because it's not the water. 200 mils versus 800 mils. That's smaller. The oxygen's smaller. So that's going to be your solute. Alright, so let's take another look. We have a positive charged lithium. Lithium chloride is dissolving in water. Well, the reason why it's dissolving is because the oxygen atoms, the positive and negative, want to come together. And the opposite true would be the chlorine. The positive and negative want to come together, so therefore we're going to pick the one with the partially positive. Okay, so which will dissolve and which is not? We have to check the polarity of each of these before we answer. That is because if we're dissolving in water, it has to be either polar or ionic, because like dissolves like. So if we're looking at this, sodium's a metal, sulfate's a polyatomic anion. This is a -2 charge. This is usually +1. Notice an actual charge and not partially and not nonpolar. That means this is ionic, which means it will dissolve. Gasoline, they say it's nonpolar. Because it's nonpolar, it has to be polar or ionic to dissolve in water because water's polar. It will not dissolve. They're not the same polarity. I2 is the same element bonded to itself. That means that there's not going to be any polarity here, which means it's nonpolar, which means it also won't dissolve. And finally, HCl. H is about 2.1. Cl is approximately 3.0 or so. There's a difference there. That means it's polar, which means that it will dissolve, because like dissolves like and water is polar. For again, ionic dissolves, nonpolar does not dissolve, and the polar dissolves. That's the end of the explanation as to why things dissolve.